Hello, so today we are going to do this problem called combination sum. So problem is part of August challenge. So what we are asked to do is we get an array of integers and the target number, and we want to return the number of possible combinations that add up to target. Okay, and the answer fits a 32-bit integer. That's not really important here, but let's see an example. So we have this array and target 4. They say combinations, but like these two here, you might say it's more a permutation, but anyway, you can notice here with this example that numbers can repeat. So you can see we can have 4 ones that are equal to 4. And we can have 1 twice, we can have 2 twice, right? And let's say the number, if the target was 6, we can have 3 twice as well, right? So the numbers can repeat, that's an important piece there. And if, let's say here target is 3, so it's not possible, so we return 0, right? Yeah, we have something here that says also what if negative numbers are allowed. We can take a look at that if needed, but how can we solve this problem? The first thing to think about is, let's just try recursion, right? And just keep trying to try all the numbers, right? And all the permutations, and then see if they sum up to target, add that to the count, and at the end return the count. So that's the most straightforward solution. We can actually start just coding it right away. So what would that look like? So we need a recursion. So what should we give as parameters? So we have target, right? That we will subtract each number we take from. So we can pass in just the remainder, right? Whatever is left. And what we want to call it initially with is the target. And we want each call to return the count of the overall number of combinations that will make this value reach 0, right? Because when it reaches 0, that means we found a combination that sum up to target, right? So if remainder reaches 0, that's our base case. But if, so here count, which means we return 1, because that's a possible way to make a combination that equals target. Now, what if remainder is smaller than 0, right? So that can happen. Let's say, for example, we have target of maybe just 2, right? And we have, first we subtract 1, so we have 1 left as a remainder. Then we subtract 2, now we have -1, right? So there is no chance to find a combination with 1 and 2 that sum up to 2. So we should just exit at that point and not count it, right? So how to do that? We can just return 0, right? So here we return 0. Next, we want to, since the numbers can repeat, right? We want to go through each number in the array and try to consider it in the combinations, because numbers can repeat. And so what we do is just we call, let's consider we taken this number, right? So each time we go through the numbers and we consider taking that number and seeing and doing the recursion to see what happens if we reach a target or not, okay? And so here, what should we do? We should remainder minus the number we've taken, which is num here. And whatever comes back, let's say we found a combination, or we found even more with multiple like recursion paths, we need to add this to our count. And then at the end, we need to return the overall count. And yeah, that's pretty much it. So here, the main important piece of this problem is to go through all the numbers each recursion call, because numbers can repeat, right? Okay, so let's run this. So seems like it works with the base cases. Let's see again. Okay, so that works there, but one thing to note is that if we run it like this, we will get time limit exceeded, because a reminder here can repeat. Like, let's say maybe we have 4, right? And then we subtract, let's say we have 6, and then we subtract 2, we have 4 left, and then we consider 2 again. So we already considered 2, we know they count with 2, and then we consider 2 again. There is no need to do the recursive call one more time. We can just cache that and then return it. So to do that, we can just have a map here that memoizes the result for us. And then here, we can say that the memo of the reminder is count. Basically, which means that if you have only this number left, then you can reach count because we already calculated here. Let's say maybe this is 5 and we were able to get 3 combinations. Then we save it so that next time we don't do the calculation again. And so how do we check? So we check if this number exists in the map. That means we already calculated it and we've already set it here, so we can just return. And this would be with the reminder, right? So let's run this. And let's submit. And that passes test cases. Okay, so now that we solved it with recursion and memoization, we can actually think about dynamic programming here. So if we think about solving it with dynamic programming, we need to determine a couple of things. What is our state? What is the goal that we want to return? What is our recurrence relation? And that's if we have that, then the order of iteration that we go through, and if we have those, then we should be able to solve it. So what's the state here? So the state, we can just deduct it from what we are asked to do, which is return the number of possible combinations that add to target. So we can have basically for our state dp of I, it can be just the number of possible combinations that add up to I, right? And what this would mean is that at the end, what we want to return is dp of target, because that would be exactly what we are asked, which is the number of possible combinations that add up to target, right? And now what would be our recurrence relation? Okay, so it would be, it's actually the answer is right here, right? So it's just the sum of dp of I minus number for all numbers in the array, right? And now what is the order of iterations we need to do? So basically, okay, let me just make sure we understand this. So for 5, let's say, right, if we have I equal to 5, then it would be the sum of all the possible combinations that add up to 5 minus 1, let's say the number here, so that add up to 4, because that would mean we can just take 4, take 1, and we have the combination, take whatever, and we have a combination, right? Or it could be 5 minus 2, and so 3, whatever is the combinations we have already for 3, and for each of those combinations we can add 2, and we have a combination that sum up to I, right? So that's where this idea comes from. And now for the order of iteration, we are looking for target, right? So we want to fill dp from 0 to target, right? So we can just go through, and the order we need is ascending order, because each time for I, we need I minus num to be present in the dp array, right? And so what this would mean is that we just need to go in increasing order from 0 to target so that we can fill this value. And so that would be just, you can call it maybe I in range of target plus 1. We are doing plus 1 so that we can reach target and fill it. And that's pretty much it. So we have everything we need. We can just start writing it up here, okay? So first we need to initialize our GP table, right? We know that the size is target plus 1 because we need the value at target. So we can just start out with 0 in range of target plus 1. Now one thing we need to think about is what is the dp of 0, right? So this is the number of possible combinations that add up to 0, right? And the answer there is just an empty list. You don't pick any number, right? And so the only combination is 1, which is the empty list. And so the base case here is 1, which means we can initialize dp of 0 to 1. And now we can just do our recursion here, and we need the sum, right? So what this would mean basically is for dp of I, we need to go through all the numbers, right? And we need, since it's the sum each time, let's just add dp of I minus num, right? One thing to note here is if we have, let's say, a number bigger, let's say maybe I is 4 and the number we encountered here is 6, right? Then 4 minus 6 is negative, so we don't want that, right? Because then in Python it will go in the negative order from right to left, and we want to have what we are in, what is our intention here. So let's consider a number only if it's valid, which means this is bigger or equal to 0. Okay. And so this is here if I minus num is valid. And then at the end, we want to return our goal, which is just dp of target. So this is just our recurrence relation, and this is the dp iteration. Yeah, and that's pretty much it. So let's run this. Okay, submit. And that passes test cases. Now, in terms of time complexity, this is O of target, right? So let's call it T, and this is O of N, the number of elements in the array. And so overall, our time complexity here is O of NT. And target is constant, so roughly O of N. And in terms of space, we are doing just one dp array of length target. Again, target is a constant, so you could say either O of t or O of 1 because it's constant space. Yeah, so that's pretty much, I think, it for this problem. Thanks for watching, and please like and subscribe, and see you on the next one. Bye.